what would be the longest distance that it will cover, right? So these are things we calculate, right, guys?
Yes,
So
sir.
we calculated, yeah, we calculated these three things. Okay. So this was time of flight, and this was height, and then this was range. Okay. So let me write those things again, and then we will do some. Uh, we'll understand about some cases, right? So this is R, this is H, and whatever it takes to reach here, so that is time, right? T. Okay, and we know that what is time. This is 2u sine theta by g, and then we have height, which is u square sine square theta by 2g, and then we have this range, which is u square sine 2 theta by g. Are these the quantities, right? U square sine 2 theta. Yeah, so these were the quantities. Okay. Now when I say that, uh, now when I say that I want to throw this object in such a way that I get this R range maximum, right? So I throw the ball, right? Let's say that you guys are playing cricket and you guys threw a ball. What you want the ball to go the furthest distance, right? In that case, what would be maximum? What would be maximum? So if you want to throw the object to the furthest distance, so in that sense, what are you maximizing? Which thing you want to be maximum? Height or range? Akib, Aram, Amna. Question for you.
Yes, sir.
Yeah, so if I threw the object, right, with some angle, right,
Yes, sir.
and I want this object to go furthest, so which thing I am maximizing?
Height.
Range.
Range. Absolutely right, guys. So I want to maximize this range, right? So this is a range, and this is dependent upon u square sine 2 theta by h. So you guys see that this initial velocity is constant, this g is constant, and the range is dependent upon this sine of theta, right? So the question is that with which angle should I throw this object so that this r is maximum? So for r maximum, this sine 2 theta should be what? You guys tell me that what is the maximum value of sine theta? What is the maximum value? What is the maximum value of sine theta that you get? Yes, guys. What is the maximum value of sine theta? Remember or not?
No, sir.
Okay, so you guys, yes, Amna, what did you say?
U cos theta.
Cos theta. So sine theta is maximum for 2 cos theta. No, maybe you are telling me the value of sine theta. This is the sine. This is what you are saying. Amna, is this what you are saying?
Yes, sir.
No, no, no. So this is the formula or the result of sine 2 theta. I am asking that what is the maximum value of sine of any angle. Okay. So you guys know that what are the values. So this is 0 degree, this is 30, 45, then what 60 and then 90. So sine goes from 0 to half to 1 by root 2 to root 3 by 2 to 1. And then after that up to 180 it again becomes what 0, right? So minus 1. So this is no, this is zero. Okay. So this is how the sine angle goes, right? So it increases and then reaches this one and then decreases and goes 0 and then increase and then. So this is how the sine behaves, right? So it is 0 at 90 it becomes 1 and then it decreases at 180 it becomes 0 and then at 270 it becomes minus 1, so this is 270 and this is minus 1 and then again at 360 it becomes 0 and this is how it goes. So the maximum value of sine is what? Can you guys tell me from this figure? Yes, what is the maximum value from this figure? uh, what can you say? What is the maximum value? Okay, so if I say that I have this graph, right? So the maximum value that are occurring is at these points. You guys correct me if I'm wrong. Are these the maximum values,
Yes, sir.
right? And what about these?
The
What are
lowest
these?
value.
These are the minimum values, right?
Yes,
So
sir.
you guys can see that at this point y value is 1 and at this point y
Minus
value
1.
is 1. So what is the maximum value of sine theta?
1.
1. Understood?
Yes, sir.
And so Elham, Amna and Akif, you guys have mathematics in your 11th class, right?
Yes, sir.
Oh, you are in 11th class. So did you guys, yeah, did you guys do this function and relation?
Sir,
Yes, sir.
I'm student.
You don't have mathematics?
No, sir.
Oh, okay, yeah. But okay, so from this point you understood that sine theta would be 1, right? Maximum. Clear? Yes. From this point it is clear, right? That sine theta
Yes,
maximum.
sir.
Yeah. So sine theta max is 1. Okay. So now we can go ahead. Okay. So at R max, this would be U square and G and sine theta to theta max, right? Sine to theta max, correct? So this is how much? This is 1. So this would be U square by G. So this is R max. Clear, guys? Is this clear?
Yes, sir.
Okay. And if so, this is so sine 2 theta is 1. So at what value sine theta is 1?
Sine 2 theta.
No, no, no. So sine 2 theta is 1. So what is the angle at which sine theta is 1?
90 degree.
90.
9. Yes, yes, correct, correct. So sine 9, right? So sine cancels and 2 theta is 90. So theta is 45 theta, right? So if I want to maximize, right? So to maximize the horizontal distance the projectile the what the angular projection should be theta should be 45. Is this part clear, guys?
Yes, sir.
Okay, so you guys please note it down and then we'll understand about the other things. Please note it down. And whenever you guys have noted it down, please tell.
Yes, sir. Finish.
Finished. Elham and Amna, what about you guys?
Yes, sir.
Okay, so we have R max, which is u square by g, right? And we have theta, which is 45 degrees. So let us calculate h. H is what? This is u square sine square theta by 2g, right? So h is at R max. What is h? So this is u square by g, right? This is 1 by 2 and then sine square of 45. So this is h and this is u square g. U square by g is what? R max by 2 and this is 1 by root 2 square. So this is h by R max divided by 2 into 2, which is 4. So R max would be how much? This would be 4h, right? And remember that I'm not writing h max, right? Because h max would be different. If I want to throw it to the maximum height, then what should be the angle? So if I am
45 degrees, sir.
okay, so I have this projectile, right? And if I want this projectile to go the maximum height, so at what angle we should project it?
For
This what
maximum height.
this 45 will degree will give the maximum R. Okay.
So, sir, then you have to find maximum height.
H, yeah, for maximum height, we should project this, right? This will give the
Yes, sir.
maximum height, right? So this is 90. So that is why I have not written it as H max, right? Because H max is different. If you want to calculate or if you want to have the maximum height, then we throw it perpendicularly upwards, right? So yes.
Yes, sir.
Okay, so this is the relation between R max and the height. And you guys please quickly note it down and then we'll do the next topic. So these are the few important things that I wanted to talk about. What would be the theta that we should project so that we get the maximum range? And at maximum range, what is the height? So these are the things. When you guys have noted it down,
Sir,
noted.
Yes, sir. Finish.
Okay, so now let us talk about the next topic, which is linear projection. So projectile motion at a linear projection. So what do I mean by linear projection? Okay, so let's say that I have this wall, right? And then what I do is that I throw the object from here horizontally, right? So I have given this u velocity horizontal. So this object will go like, right? So the object will go like. So this is what we call the linear projection. For the case of linear projection, what is the theta angle? Or forget about the theta angle. So do we have any vertical component of initial velocity? Yes,
45.
theta is 45. Okay. So when we projected the projectile like this, so this was the, right, this was theta. But now we are projecting from here. So does it have any y component joint? But, okay. Yeah. So do we have any vertical component? Does this u has something like this?
No, sir.
Right. So it has nothing in the vertical part, right?
Only horizontal.
Only horizontal part. Yes, correct. So u has only ux, right? Because we can write this u as uxi plus uyj, but it has only I hat direction, no j hat direction. Am I correct or wrong, guys?
Yes, sir.
So u is only ux, right? It has only horizontal component.
Yes, sir.
Uy is, this is the initial condition that I have, and this height is h. This height is h, and this is my range. Okay, so you guys tell me that. Let's see that this this height is h, right? And what is the acceleration that I have? This acceleration has x component and y component, right? But you guys can see that we are only, the acceleration is only due to the gravity, right? So we have only this acceleration. We don't have acceleration in the, in this direction, right? So we have only ay, which is minus g, and ax is 0. Understood, guys?
Yes, sir.
Okay. And let's say we want to calculate this distance, right? This r. Okay. So which component we will use? Which component we will use?
Sorry, sir.
Which component of the kinematics equation we will use?
X.
X component, right? So let us write the X component equations. So first is what? Vx is ux plus at, right? We know that ax is 0. So Vx equals to ux. So Vx equals to ux, which is u. So it will have the same velocity, right? Which means that in x direction, I don't have any acceleration. The velocity is constant in x direction. Understood, guys?
Yes, sir.
Okay. Now let us calculate the second, which is x. X is how much? X is r, right? And this would be how much? This would be ux of, but let me first write the equation. So this is x, which is uxt plus half axt square. Okay, clear?
Yes, sir.
So ux is how much? X is how much? X is r. Ux is how much? This is u, and t is t, right? And ax is getting cancelled, so r is simply ut. Clear?
Yes, sir. Clear.
Yeah, Elham and Amna and Abdul. So Abdul, is this your first class? Yes, Abdul, can you hear me? Okay, so maybe you are hesitating to talk. So we can also write it in the chat box. If you have any doubt, any problem, you can also write it in the chat box. Okay. Yeah. So this is range, and this is u, and this is time, right? So we want to calculate what is this t. Okay. But we know that this is h, right? So from this we can calculate. From H, we can calculate who got disconnect. So Abdul got disconnected. So from Y component, right? From Y component, we can calculate the time, right? So using the Y component, we know that H is how much? Or Vy, Vy is Uy and plus Ay, right? So Vy is how much? This is Vy. Uy is 0 and Ay is minus of this is what? G and T. So this is my Vy, but we don't want to calculate Vy. We want to use the second equation. So second equation is what? Y is Uyt plus half Ayt square. Okay. And Y is H. This uy is 0 and this is minus of this is what, half gt square. Okay, so we are getting this negative sign because we are calculating the distance from this point, right? From this point we are calculating the distance, so we can write it as positive, right? So this is half gt square. Okay, so T is what? T is 2H by T. So this is RT. Is this clear to you guys?
Sir, how it became positive?
Yeah, so we are measuring from so this only depends on where from we are measuring, right? So if we are measuring from this point and we are going downwards, so that is negative. But if we
Yes,
are
sir.
measuring from this point, if we are measuring from this point and we are going in this direction, so this is positive. Is this clear?
Okay, sir. Yes, sir.
Yeah, this is only dependent upon from where we are measuring, right? So this distance will always be positive, so we can take it as positive. Is this
Yes,
clear?
sir. Yes, sir. Clear.
Okay, so please note down this part. This is the linear projection. Okay, please note down from here. And whenever you guys want me to scroll down the screen, you guys can tell.
Finished, sir.
Finished. This part also.
Yes, sir.
Okay, so yeah, and Amna and Elham, what about you guys?
Done,
Yes, sir.
sir.
Okay, and you guys can think it this way also. So you see that if you write the velocity, right? If you write the velocity, so you see from here that velocity is in this direction. This is minus j hat, right? Velocity component would be minus j hat. Is this clear? Because this has this velocity and this velocity. So x is positive, but y is what? This is minus j hat. So in this way, you are getting this minus, right? And similarly, you can see from here that this distance, right? When you write the distance, so this is xi plus yj. Okay, but you guys can see that this is going in this direction. So x is positive, but y is in which direction? Y is what? Y is minus j. Clear? So that is why this distance is negative. You are getting this distance negative, and you can tell that the magnitude would be positive, right? So that is
Yes, sir.
how we can see the direction. Okay.
Yes, sir.
Okay, so these are the things that we should know, right? And yeah, so remember that when we want to calculate the height, we use this half gt square, and when we want to calculate the range, we use this ut. Clear? Okay, so let us do one question, and then you guys will understand it more perfectly. So let's say that uh, an aeroplane is moving with 20-meter per second velocity. Okay. A supply, right? A food supply. A food supply is thrown or dropped, right? Dropped from the plane. Where should the boy be placed so that he gets the food on the ground? Right. This is the first question, and the height is given. The height of the aeroplane is let's say 100 meters. Okay, you guys think about this question, right? So what do you guys know? We know that h is half gt square, right? So let me write it as 200 meters. Okay. So h is half gt square, and r is what? Ut. This we know, right? Is this clear? Is this clear, guys? So this is h is half gt square, and r is ut. This is what we do. Clear?
Yes, sir.
So in this question, this plane, right? So this plane is okay. My drawing of the plane is very bad. So this is, we have this plane. Okay. So this is the plane which is moving, right? And some object is dropped from there, right? So this will drop like this. Okay. So it has some velocity, which is what, 20, right? So this is 20 meter per second, right? And it has been dropped from here. So the boy is here, right? The boy is here, and how much distance this boy has to cover to get that? So this is what? Height or range? What we need to calculate? Yes. What do we need to calculate? So this
Range.
distance, range, right? We have to calculate this range. This distance the boy has to cover,
Yes,
right?
sir.
And the height of the plane is given, which is 200 meters, right? This is given, right? And this initial velocity. So this is when this problem comes in hand. Is this clear?
Yes, sir.
Yes, sir.
Okay, so we know that R is UT. We need to calculate. We need to calculate this range, and U is given. What is the thing that we need? U, we know this is 20 meter per second. Time is not
Um,
given. So we have to calculate this time. So from where we can calculate this time? Yes, from where we can calculate this time? Yes, guys. From where we can calculate the time? Okay, let me change the question a little bit more. So we have this 2000 meter. So from where we can calculate the time, guys? Akib, Elham, Amna, and Abdul. Oh, Khadija
Yes, sir.
has come. Khadija has come. Okay. Yeah. So, Assalamu alaikum, Khadija. You are late, and you are very late. Yes. So, from what we can calculate the time using what? So, does this relation have anything that we can use? Does it serve the
Yes, sir.
purpose? Right? We know H, we know G, we can calculate time. Correct?
Yes, sir.
So, first let us calculate the time. So, H is 2000 meters, right? G we know. So, using H, this is 1 by 2, this is 10, and this is T square. So this is what? This is 2000, right? And equal to, this is 5 t square. So t square is how much? 2000 divided by 5. So this is 400, right? So t square is 400. So t is how much? Root 400, which means 20 seconds, right? So t is 20 seconds, which means that h is r is how much? So R is 20 meter per second into 20 second, which is 400 meters. So the boy has to cover half kilometer, right? Nearly half kilometer to get his food. Is this clear?
Yes, sir.
Okay, so please note down the question. Please note down the question and the answer. Yes, Khadija. So in the previous part, we did the projectile with some angle, with some angle. That was the angular projection. But now we are studying the projectile motion with the linear projection. So in this part, we don't have any, right? So this is the motion of the projectile motion. We have only this velocity, only the horizontal ux, which is uy is zero. Okay, whenever you guys want me to scroll down the screen, you guys tell.
Sir, can you scroll down?
Done, sir.
Noted. Okay. What about,
Yes.
yeah, you guys have also noted. So, okay, now let us do the next topic, which is relative velocity. So projectile is completed. If you guys have any questions from projectile, you guys can relative velocity. So we have understood about this relative velocity in the one dimension motion also, right? So okay, so we have understood about this problem in one dimension motion, right? But now the object or the body is traveling in two dimensions, right? So the object is traveling, let's say that in two dimensions. Okay, so this is some VA and this is some V. So two objects, whenever we talk about relative velocity, which means that two objects are, both the objects are moving, right? So both objects have some velocity, right? So let's say that, and let's say that these are the two velocities, VA and. So if we want to calculate the relative velocity of A to with respect to B, right? So we write it as VA, right? And we you guys already know what is this VAB. This you guys have already learned. So what is this VAB?
Sir, A minus B.
VA minus VB, right? Correct. Is this clear?
Yes, sir.
Yes, sir.
Okay, so this relative velocity comes in very handy when, yeah, so this is relative velocity in two dimension. Relative velocity in two dimension. So in the previous chapter, we talked about relative velocity in one dimension. Okay, so yeah, so this problem comes in very handy when we use this rain umbrella problem. right? So rain man problem. This is okay. And this is also called the umbrella problem. So you guys use always use. So let's say that you have. So let's say that these are the directions. Okay. And let's say that the man is moving in this direction. Man is moving in west direction. Okay. And the rain is following in the south direction. So rain is falling like this. This is rain, and man is moving in the west direction. So man is moving with let's say 3 meter per second, and the rain is falling let's say 4 meter per second. Okay. So the question is that where should where should the man place his umbrella? Okay, this is the question. And remember always that whenever you see that the man is moving, so note that, right? When man is moving, use relative velocity. Okay, this is one. And when man is not moving, use resultant velocity. Is this clear?
Yes, sir.
Yes, sir.
Okay, so what we do is that this is the velocity of man. So the man is moving, right, in the west direction. So can you guys tell me what would be the vector of man? What would be the vector of man?
Sir, we should do 4 minus 3
No, no, no. I am asking that what is the velocity? How can we represent this velocity in vector form? So velocity of man in
minus
vector
I minus
minus.
3.
Yes, yes, absolutely good. So minus 3i, right?
Yes, sir.
And what is velocity of rain?
Plus 4
So the rain is
K.
going upwards. Rain is going upwards. So plus 4 k. K means that it is coming at you, right?
So J minus 4J.
Minus 4 j, right? Absolutely right. So minus 4j. Because it is falling down, right? So y-axis, we are only confined in 2 dimensions. So we don't have
Yes,
any
sir.
case. We don't have any z-axis. We don't have any case, right? And yeah, so we have only x and y, which means we only have I hat and j hat. So man is moving in west direction, right? And the rain is falling down. So falling down is minus j hat. So these are the two vectors. Is this clear, guys?
Yes, sir.
Clear? Amna, Ilham, and Khadija, clear?
Yes, sir.
Okay. Now we want to calculate. So you guys see that both are moving. So now we want to calculate the velocity of rain with respect to our man, right? So this we want to calculate, right? So we
Yes,
want
sir.
So we are calculating the relative velocity because both the man and rain both are moving, right? So this would be VR and minus VM. Okay. So this would be what? This would be VR is minus 4J and this is minus of minus 3R. So this is what? Minus 4J and plus of 3R. So this is velocity of rain with respect to man. Clear? Is this clear, guys?
Yes, sir.
So the rain is falling like this. This is rain, right? And this is man. So what you do is that you take the negative minus, right? So Vm is negative and you take the negative of this Vm. You take the opposite of this Vm. So this is the Vm, right? Negative of Vm, and then you take this direction. So this is your relative velocity, VRF. Okay. And then this is the theta that it is making. So when you calculate this theta, right? So what would be this tan theta? What would be this tan theta? Yes, this is 4 and this is 3. So what would be this tan theta?
So 3 by 4.
3 by 4, right? So what is this 3 by 4 angle?
Value.
Yeah, value. Whenever we have this 3, 4, 5 triangle, so I have this is what? P is 3 and base is 4 and this is 5. So I have told you guys that what is this angle. So this is 37 degree, right? So
Yes, sir.
theta is 37. So this is the angle at which the man has to place his umbrella, right? So this is the angle that at which the man has to place his umbrella. Is this clear?
Yes, sir.
So
Yes, sir.
this is
Yes, sir.
so please note it down. Please note it down from here. So remember that the man was moving, right? Now we will do a question when the man is not. And whenever you guys want me to scroll down the screen, you guys check.
Finish, sir.
Yeah, whenever you guys
Yes, Done, sir.
Oh, one moment, one moment. So okay, yeah. So this is okay. What would be the angle? So you said Akib 3 by 4, and so this is what? What is the angle? Sorry about that, guys. So this is 3i minus 4j, 3rf. So what is tan theta is what? If I have yeah, so Akib said 3 by 4, and then okay, so I have this theta, and this is y, and this is x, right? So what is y in this case, and what is x?
Sir, X is 3i.
X is 3, right? And y is minus. So
Yes, sir.
tan theta would be 4 by 3. And minus, so theta would be negative. So let's take theta as positive. So this would be 4 by 3. So theta is tan inverse 4 by 3. Okay. This is, so this would be the answer, not 37. Okay, guys.
Okay, sir.
Yeah, this would be the angle. So please correct that part. Corrected, guys?
Yes,
Yes,
sir.
sir.
Okay. Now what we do is that we have another case. So this is also the Rain Man problem. But in this case, what is happening is that the man is stationary, right? So we will not use the resultant, the relative velocity. We will use the resultant velocity. Okay. So what is happening is that we have the rain which is falling down. So this is VR, and then the wind is blowing. So we have this wind, right? This is wind. Okay. Now the question is that where should and here the person is standing. So in here the man is standing, and where should he put the umbrella, right? So in this case, what we do is that we calculate the resultant, right? So the resultant would be what? So we have this the wind is minus of, let's say this is 3 meter per second, and this is 4 meter per second. So velocity of wind is minus 3i, and velocity of rain is minus of 4g, right? So velocity, now we have to calculate the resultant velocity. So we are, this would be what? This would be simply minus 3i plus minus of 4g. So this is minus 3i and minus of 4g. So this is the result. Okay. And if I want to calculate the magnitude, so this would be how much? This would be simply 3 square plus 4 square. So this is 5. So this is the velocity with which the rain is pouring down, right? Now we have to find out the angle with which we should place or hold the umbrella. So in this case, we'll have to hold the umbrella in this direction. So this is east, and this is north. So we will hold the umbrella. So this is theta, right? Theta is how much? For this theta, right? This theta would be how much? Yes, this is 4, this is 3. So tan theta would be how much? Oh, yeah. So this is the theta with the horizontal. Okay. So tan theta would be how much? Yes, guys. Tan theta would be how much?
Sir,
Yes.
3/4 here.
Yes. What do you say?
4/3.
Yes. Tan theta is again 4 pi. Right. So theta is again tan inverse 4 pi. Okay. So this is this theta. So the man has to hold his umbrella, right? From this in this angle he has to hold his this umbrella. So this is tan theta, which is tan inverse 4 by 3, and this is in east north direction. So northeast direction. Okay. So is this problem clear to you guys? Whenever the man is stationary, so we will use the resultant one, and whenever the man is moving, then we'll use the relative one. Okay. So did I again? Yeah, so this is for this case, this is theta, right? So in here, so this is the theta, this one, right? And from vertical, when we calculate, so this would be the theta. So this is my theta. Okay, please note it down, this part. Yes, any doubt, guys?
No, sir.
Please note it down.
No, sir.
Yes, whenever you guys have noted it down, please tell.
Yes, sir.
Sir, done.
Done. Amna, what about you? Khadija, you have noted it down. So, Amna, what about you? Yes, Amna, noted. Who got Amna got disconnected. Okay. So, whenever, right? Whenever they ask about moving man, right? Moving man, then you guys use the relative velocity. And whenever they ask you about stationary man, then you guys calculate the result. Okay. So in this relative velocity we use subtraction of vectors, subtraction of vectors, right? And a resultant is addition of vectors. Okay. So and in here, right? So in the answer, you can write any of the theta. So you can write this theta or you can write this theta. So whenever you are, so for this theta, you say that this theta is making an angle with the east direction, right? So this theta is making an angle with east direction. And if we are measuring the angle with the vertical part, right? From the vertical, then this would be the theta dash. Okay, so if you write that this is the angle that you are getting, so this would be the angle from the vertical, right? And this is the angle from the horizontal. So you can write any of the angle in your answer. But remember that whenever you write this angle, right? So whenever you write this angle, so for this angle, the tan theta would be what? For this angle, tan theta would be, this is 3 and this is 4. So for this angle, tan theta, let me write it as theta dash. So tan theta dash would be 3 by 4, right? But for this angle, this would be, tan theta would be how much? This would be 4 by 3. So you can measure your angle from the anywhere, right? So let's say that you are placing the umbrella like this, and you are saying that it is from the east direction in this angle. So this is also correct. But when you say that from the north direction, this is my angle. This is my angle that I am placing the umbrella. So both the answer are correct. This, it is just the case that from where you are measuring the angle. Is this part clear to you guys? Yes. Is this
Yes, sir. Clear.
yeah? So, but why did I write 3 by 4 and 4 by 3 for this case? Can you guys tell me why did I write 3 by 4 and 4 by 3? Yes.
Because it is taken from horizontal.
Yeah. So for theta dash, for theta dash, this is
Oh,
my, for theta dash, this is my base, right?
yes, sir.
And this is my perpendicular, right? For theta dash, this is my perpendicular. Tan theta is what? This is perpendicular by base, correct? Is this
Yes, sir.
correct? So for this theta dash, my perpendicular is 3 and my base is 4. And for this theta, tan theta, my perpendicular is this 4 and this is my base, right? So that is why this is 4 by 3. Okay. In here, 3, for this case, theta dash is 37 degree and this is 90 minus 37, which is 53. So these would be the two angles. Both the angles are correct. So if you write 53 degree, if you write 53 degree from the east, so this is also correct. Or if you write 37 degree from the north, so this is also correct. Elham, Amna, oh, Amna got disconnected. Elham, Khadija, and Akib. Is this thing clear to you?
Yes, sir.
Yes, sir.
Okay, so then let us move ahead, right? We did both the questions. So one was this uh, relative one, right? And the other one was this stationary one. So these are the kind of questions. Now the next topic is uniform circular motion. So, can you guys tell me what is uniform motion? You guys have, so we have already talked about uniform motion. For uniform motion case, what is, what do you call a uniform motion? Yes, Kalam, Khadija, Akib, what is uniform motion? Oh, Amna has come back. Okay. Yeah, Amna,
Equal distance cover.
equal distance in covered in equal interval of time, right?
Yes.
So which means that if equal distance is covered in equal interval of time, so that is uniform speed, right? Right.
Yes, sir.
Which means that my speed is constant. So whenever I say uniform motion, right? Uniform motion, which means that speed is constant, right? So speed is uniform. Clear, guys? Is this clear?
Yes, sir.
Okay. So, but what is this uniform circular motion? So if the object is confined in the circle, if its trajectory or if its path is confined in the circle, so then that kind of motion is called circular motion. But we have uniform circular motion. So for uniform circular motion, uniform circular motion. So for uniform circular motion, the magnitude of velocity is constant. What do I mean by that? So let's say that we have this radial distance, right? And at this point, this is the tangent. So this is my velocity, direction of velocity. At this point, right, this is my distance, right? Position vector. And then this would be my velocity. Okay, and at this point, this would be my velocity. And at this point, this would be my velocity. So this is the example of uniform circular motion. We can see that the magnitude of velocity is same. What is changing? In all these places, what is changing? Yes, what is changing, guys?
Sir, direction.
Yes, direction of velocity is changed, right? Magnitude of velocity is constant, but direction of velocity is changed. That is why we say that the velocity is changed. Although the magnitude is same, right? Magnitude of velocity is same, but the direction is changed. Okay, and let's say that the object has the object started from here. So this is R1 position, right? And then it reached here. So this is R2 position. So what is the displacement that it covered? This is the displacement, right? So this is the displacement that it covered. So this is delta R. Okay. So this is delta R. So what would be the velocity? what would be the velocity? Let's say the time taken is t. So what would be the velocity? Displacement upon time, guys, right? Is this clear? So let's say that is this clear, guys? So this
Yes, sir.
is let's say this is V1, and let's say this is okay. So delta V would be right. This would be delta R by delta T. Okay, and we have this uniform circle. What are the attributes of first circle? So let us talk about that. So, so we have talked about all the distances, right? We know about distance. We know about displacement. We know about velocity. We know about what? We know about speed, and we know about velocity, and we know about acceleration. Okay, but all these were when we were moving in a linear direction. So all these were linear, linear displacement, linear speed, linear velocity, and linear acceleration. But the body is moving in circular direction. So there would be a rotational analog of that, right? So this is a rotational motion. The body is moving with some axis. So let's say this is some axis of rotation. So let's say that this is some axis of rotation, and the object is right. So we have this kind of motion, or let's say that we have this is the axis of rotation, and the object is moving like this. So this one. So this is what we call the rotational or circular motion. Understood?
Yes, sir.
So whatever the physical quantities that we had that define the motion of the object, so this will have some rotational analog, right? So this will have some rotational analog. So the distance or displacement would be changed by angular distance or displacement. Angular distance or displacement, and then this speed or velocity would be changed by angular velocity, and the acceleration will be changed by angular acceleration. Okay, so these are the rotational analog of linear motion, right? In circular motion, all these things change to this one. So if the object is moving, started from here and it reached here, right? So this is the linear displacement that it covered. This is the displacement that it covered linearly. But angularly, this is the distance that it covered, right? So this was some initial position, and the object reached here. So this is the displacement that it covered angularly. So this is called the angular distance displacement. Is this clear to you guys? Is this clear? Yes.
Yes, sir. Clear.
Okay, so now let us let us write all these quantities. So what is the angular displacement? So we have this object, right? So it was here and then it finished here. So this was the initial point and this is the final. So this will be called the theta, right? So the angle that the object has made from the initial point, right, which is, let's say this is 0 to the final point, let's say this is 1. From initial point 0 to final point is called the angular displacement, right? And this is a vector quantity. So this is a vector quantity, right? And precisely this is an axial vector, right? Why do we call this an axial vector? Why do we call this an axial vector? Because it has some axis of rotation, right? So why do we call this an axial vector? So we have this axis, and through this axis, what is happening? Yeah. So we have this axis of rotation, and the object is moving through this axis of rotation, right? So we have this axis of rotation like this, and the object is moving with some angle. Okay. So whenever something has axis of rotation, so that kind of vector is called the axial vector. Is that clear to you guys?
Yes, sir.
Okay,
Yes,
so
sir.
we'll talk about this in more detail and then we will derive. Yeah, so you guys write these things and then we will talk about this in more detail. Okay, you guys, yeah, so tomorrow we'll be able to finish this chapter. And you also have this uniform, not the uniform, but circular motion in the next chapter. Laws of motion, you have this circular motion. So we will talk about that in that chapter also. You guys quickly note it down. So
Finished, sir.
Yes, sir.
then, okay, then note down this part.
Yes, sir.
Okay, so then note this part. So we will talk about the direction of this angular displacement and the angular velocity in the next class. So tomorrow we will finish this chapter.
Yes, sir. Done.
Then Amna, Akib, and yeah, Ilham.
Yes, sir. Finish.
Okay, Khadija, what about you? Noted.